Hi everyone, welcome to today's webinar on the emerging trends in private networks for mining. My name is Daniel, I work at IBWave in marketing and I'll be your host for today. I would also like to welcome our speaker, Dean Bubley from Disruptive Analysis, and our co-speaker, Milton Malva, who is a sales engineer at IBWave. In the first part, Dean will cover the current challenges and also the new trends in the mining sector. And in the second part, Milton will show you some real cases and examples from the mining sector as well. So just before we start, I would like to go with you through a few housekeeping items. So our webinar is going to be recorded and you'll receive a copy in your email in the next few days. And I would also like to encourage you to ask your questions in the question box, and we will go through them at the end in the Q&A session. For those questions that we won't be able to answer today, we will get back to you by email or we create a piece of content that will address them. So that's all from me, and I'm going to hand it over to Dean. Enjoy.
Thanks, Daniel. And hello and welcome to the introduction section for this webinar on private networks in mining, primarily looking at cellular networks, 4G and 5G, but I'll also be talking about Wi-Fi and other technologies as well. And so I'm going to be talking through some of the use cases, the rationales, why public versus private networks, in which situations. I know there's quite a mix of people on this webinar. There are some people from the network industry who are looking to understand more about opportunities in mining, and there are some people from the mining sector and their solution providers who are looking to understand more about what's happening in cellular networks. So I'm going to try and address sort of both sides of that, and there's probably a few other general observers, commentators, other analysts as well. So as a quick background, I'm an industry analyst and advisor. Some of you may know me on Twitter as Disruptive Dean, and I've been a telecoms and technology analyst since 1991. And in fact, I've been following private cellular networks. I realized the first time I saw an enterprise small cell was in 2001. It was a GSM picocell. And obviously, in the last few years, we've seen something of an inflection point in enterprises deploying their own mobile networks, especially with the rise of 5G. But there's a long history here, and I'll be talking a little bit about that. I'll maybe reference some other industries. I am not a specific, I don't have a specific focus on mining. I cover lots of verticals. Some of you may have seen me do webinars before on utilities and transportation and other sectors as well. And as well as the technology side, I also look at aspects of policy, and I'll be talking about spectrum and how that relates to private networks, and also the role of service providers and others. So outside of this, I do quite a lot of work on the future of 5G and now 6G in the distant future, Wi-Fi 6, 7 and more, satellite communications and other technologies, as well as the use cases, applications, ecosystems and policies. So mining, some sort of global top-level context. It's a big industry. It is one of the world's largest economic engines, particularly in some countries, which obviously have particular mineral resources. The numbers vary from year to year, but if you said it's around $2 trillion revenue, that's a reasonable sort of ballpark figure. Obviously, there's a large amount of pricing volatility for some minerals, so that can flex up and down, but it's a substantial part of many countries' economies. It has around about 20 million employees globally. Depends a bit whether, where you define the boundaries of the industry, whether it's just large companies or sort of smaller or informal mining. But obviously, for the purposes of this, we're looking more at the large scale operations and particularly national and multinational level companies. And there's, I've seen estimates of between 50 and 100,000 sites. Yes, again, some of those will be quite small, but some will be huge, many sort of tens of square kilometer sites in some places, as well as associated infrastructure such as rail and port and shipping facilities dedicated to mining operations. And despite the size, there's a lot of changes, challenges, and trends, even before you get to the networking aspects, that are driving the future of the industry. Probably the most prominent are around safety, and I'll mention that at several points here, and also around decarbonisation. And that has implications for both the types of mines, the types of mineral, and the ways in which they are operated as well. So obviously, on a long-term view, we can probably expect coal to diminish in importance, although at the moment, with energy crises in various parts of the world, it's actually on an uplift again, perhaps unexpectedly. On the other hand, in future, we can expect more copper that gets used in things like electric motors and cabling, perhaps uranium as well. And so the demand mix is going to vary, and so likely the supply will, and there will be some new mines that come online and others which are end of life and have remedial action taken to maintain the environment where they were. There's a big focus on safety in the industry, particularly worker safety, and that's going to impact increasingly the levels of automation, things like remote control of otherwise dangerous machinery, but also monitoring of what's termed geotechnical aspects of mines. For example, whether there's a waste tailings pond or a dam or something like that. There have been incidents in the past where there have been catastrophes, so there's now a lot more sensors, cameras and so on that are being used to ensure that there are no sort of larger scale risks and dangers. Same thing underground in particular, there are issues around whether it's gases or leaks or potential sort of mine instability. So there's a big emphasis on monitoring, improved controls, and also remote capabilities. There's obvious, like in every industry, a big interest in security, and that's both physical site security, but also cyber security as well. And particularly with automated machinery and the values involved, that means a lot more focus on integrity of networks and data assets. And then there's a whole slew of innovations around Industry 4.0. And some of this is familiar from other industries, things like preventative maintenance and sensing for wear and tear on machinery. There's data collection to improve supply chain management between different sites or upstream and downstream operations within a more integrated company. But there's also an important aspect here in the pricing and volatility and the geopolitical changes we've seen in a lot of sectors has meant that mining companies need to be much more agile about deploying capital, about deploying human and physical resources, machinery to different sites or different parts and different roles. That requires data, it needs situational awareness, and it also needs to have optimization of resource usage. And all of this is very, very data intense. And we can expect, certainly in the larger and more modern mining environments, for data collection and data activity, including in some cases edge computing, to drive demands for networks as well. So it's worth noting that mining is a very diverse sector in terms of the physical site and operation and where applications and networks must be used. The most obvious divide is between above ground and underground mining. Obviously, that has a huge implication for the types of wireless network and how coverage is designed. There's some particular challenges around underground, obviously, but even above ground, you have steep-sided pits, which may have lots of shadowing effects, as well as more interest in sort of what spectrum you use to enable dedicated access in the pit without causing interference more broadly. Underground, that's less of an issue. You've got moving vehicles, you've got huge stockpiles of mined output. And that's important here is that the topography of the mine can actually change over time, where there may be many thousands or millions of cubic meters of material that are moved around, as well as blasting, which can sort of excavate the sides of pits. So it's not like a site in, say, an industrial site or a factory where it's fairly static in nature. The unpredictability and dynamic environments for mining pose specific challenges for networking, including how you deal with putting fiber in or equipment in, which may need to be moved around. There's other physical infrastructure elements which sort of overlap with some other industry sectors. So you have dedicated railways for mines sometimes to take minerals to a port or to some other interchange for trucks or other onward shipping and processing capabilities. The processing plants are sometimes on site, sometimes separate. You've got accommodation blocks and various sort of wider environmental monitoring, particularly around pollution. So all of those will have diverse set of connectivity requirements over, in some cases, a very large area. And this is why cellular technology is becoming more important. And certainly it's not the only one. I'll talk about later on about the diverse network options and where you would use different technologies. But cellular, and particularly 4G and increasingly 5G, have certain standout characteristics that make them suitable for many applications. The most obvious one is mobility, and cellular networks are inherently designed for moving people, moving machinery, moving vehicles. And that aligns with coverage, but also includes the handoff from one cell to the next as well. Coverage is important, and coverage is often determined by the power levels allowed in any given slice of spectrum. And what we typically find is that licensed spectrum, even if it's locally licensed for the mine, will often allow for higher power levels than unlicensed bands, which are more familiar for Wi-Fi use. That's not to say unlicensed isn't useful, but it has tendency to mean you would need more radios to cover a given area. And that may be fine inside the main mining offices or perhaps warehouses or some parts of an underground environment, but to cover large expanses of open air quarry or pit, it's more likely that a higher power radio will be used. And it's the combination of that coverage with throughput and latency. So some of the low bandwidth UHF and VHF systems for critical voice communications are fine in terms of coverage, but they don't allow for transmission of high definition video, for example, on the uplink, or remote control, which has two-way communications needs for machinery. You might have video one way and control signals the other, which obviously need to be high performance given the inherent risks and values involved. Standardization and vendor ecosystem obviously benefits in the cellular industry. There's a lot of choices of suppliers of both the radio equipment and the modems and other devices, handhelds, could be gateways, could be vehicle mounted equipment. And that tends to be, particularly for 4G today and 5G increasingly, a lot more choices available to the either the mine operator, a service provider, or an integrated solution provider. In future, 5G will also have additional enhanced capabilities. The current edition of 5G, which is sometimes called Release 15, has some, but as we see evolution of 5G in the next 3 to 5 years, it will bring in better capabilities for positioning and some more fine-grained control over quality of service, maybe using a technique called network slicing, but there's other mechanisms as well. And the last point I'll mention here is a fairly good base of skilled users, of skilled deployment, operational engineers, and just understanding more broadly. Now, it's still not as large as the Wi-Fi base of engineers, probably by a significant margin, but we're seeing a lot more emphasis in training on people who can understand how to deploy and run mobile networks in an industrial setting. So, this chart has some of the use cases. There are many of them. The next slide, I've got a longer list. So if you download the materials after the event, you've got a more detailed look, and there's an ebook which is being published, which goes alongside this as well. But some of the most important use cases that I'm seeing in the mining sector, I've mentioned remote controlled machinery, and obviously there's a large range of solutions there, whether it's cranes, whether it's excavators, whether it's moving vehicles, whether it's shearers for rock surfaces and others underground. There's a big set of activities here to allow some machines to be used centrally from a control center rather than with a human operator in a vehicle or next to it. And that has offers improvements in productivity, for safety, even worker diversity. It allows for a much broader range of people to be able to operate machinery which they might not be able to do in person on site. There's a lot of emphasis on critical communications and going beyond voice to sort of push to video and see what I see models of critical comms, perhaps also with streaming data on health indicators for a worker, such as heart rate or body temperature and so on. There are some already fully autonomous systems, particularly things like mining trucks, and that allows for 24/7 operation. It also allows for optimized use of throttle and braking and steering, so that things like wear and tear on tires can be minimized. And also fuel consumption of some of these mining trucks can be 400 tons. And there's significant energy use actually in the machinery. And over time, we could expect that AI and machine learning techniques should optimize the utilization and sort of driving profile to improve the productivity and asset utilization. There's monitors of varying sensors, from motion sensors to perhaps video cameras, which are used both to detect dangers in certain situations or changes in the surface of a rock face or a dam. You've got security cameras also used for perimeter security around the mine, obviously important for all sorts of reasons, as well, from legal compliance to physical security of equipment, of valuable equipment, and of course raw materials as well. There will be certain indoor type use cases. It could be training, it could be the indoor processing systems which will require connectivity. And it's like any industry. There are hundreds, perhaps thousands of use cases. And initially networks will probably be deployed to target one or two. And then over time, additional use cases, perhaps with additional coverage, will be added in. I haven't shown on that picture, but there's ventilation management, water management, and a long list. A lot more description in the ebook. Some more comments here, and you will like to see increasing use of things like machine vision in varying guises. That's important because that is very heavily uplink centric, and that would need more data going upstream to the network from the user. I have a model I use when I'm talking about enterprise cellular networks as to sort of private versus public networks and what makes sense in what locations. And if you like, I sometimes refer to them as the 5 Cs. And probably the most obvious one for mining is this issue of coverage. A lot of mining is in remote locations, whether that's exploration or production mines. There is no public network often in a lot of these places, and then even more so where they are underground or deep inside a pit, there almost certainly will be no public network coverage at all. So this is probably, of all the industries, probably the easiest to justify private networks just on the basis of coverage. Often you've got mines in remote areas, could be the outback in Australia, it could be the far north of Canada, or the Andes in Latin America. You've also got on-site coverage along, again, it could be a dedicated railroad, it could be the industrial facilities with metal walls for processing. As you can understand, this is probably the primary driver and one of the reasons why mining has been at the forefront of private cellular for more than 10 years in terms of early adopters. The other thing is control. And control's got lots of dimensions. There's the security, but also because of the remoteness, they may well need an on-site network core, which is controlled on the mine site. This is not one of those industries where you can necessarily rely on a centralized core network run by a carrier hundreds of kilometers, even thousands of kilometers distant. You might have to be reliant on backhaul via satellite because you may not be able to get fiber to the site. So you will need to have a fair amount of control capabilities on site, if not a completely dedicated and isolated network. There are some applications here which go beyond what can be done with Wi-Fi, and particularly around mobility and the vehicular use cases. Whilst there are industrial mesh systems, they may struggle with some of the distances involved in some of the mines, just from a number of access point requirements. I would say cloud integration is at early stages in some cases, but there is likely over time to be tighter coupling between private networks and cloud deployments. And if like the balance here is interesting, is do you put the private network as part of an edge cloud infrastructure, or is the edge computing part of the network? And depending which way you view that, and the vendors involved may lead to slightly different choices around the technology. There's obviously some cost issues. I would say of various industries, mining is perhaps not the most cost sensitive, although with the price volatility and the economic returns being uncertain because of geopolitics, that may change over time. But there's certainly interest in replacing things like legacy private radio and potentially fiber if it needs to be moved around a lot. The last one, in terms of compensation, most mine sites are not multi-tenancy, so you don't have some of the sort of property company or type business models around private networks. But obviously the main payback is through improved productivity. There might also be some fixed wireless access or mobile coverage provided to surrounding areas and communities, although that might be funded by government rather than as a revenue source. So what that tends to mean is that the mobile operator, so MNO for those from the mining industry stands for mobile network operator or carrier. It's a typical telecom service provider. Originally, they were expecting to provide a lot of enterprise private networks as a slice of their national networks, as like a slightly customized virtual offcuts of that network. I would say in mining that is currently relatively unlikely, and what is more common are models where the enterprise has its own private or dedicated network. Now, in some cases, that will be run by the mining company. In some cases, it will be run by a specialist service provider, and there's a number of mining service providers in different parts of the world. And in some cases, it will be a specialist division of a traditional telecom operator. So a couple of telecom operators I'm aware of have a dedicated mining services business unit, which can make its own decisions about vendors, about spectrum. It will be pragmatic and aligned with the requirements of the end user concerned. So I think that this is definitely one of the sectors where there is much less debate around public versus private networks. It's likely to be a dedicated infrastructure of some sort, but that may be run by a traditional service provider or a newcomer. I would say in terms of number of sites, obviously it depends. Each country has a very different profile of how important mining is, depending on the size of the country. So the world's largest country is the sort of Russia and Canada, Australia, and so on. The physical size, China, Brazil, various others, they will tend to have large mining districts, but they may be very remote areas. And I expect you'll see a lot more development there. And in fact, some of the companies that have developed solutions today have origins in markets such as Australia, which is among the more advanced. This is just a sort of a list of some publicly announced mining projects using private 4G and 5G networks. It's far from being comprehensive. It's difficult to estimate how many mines already have a private network, but I would say some sort of private cellular in maybe 100 to 200 is not an unreasonable estimate, although that might not be for multiple applications in multiple places, and some of those would like to be test beds rather than full production networks. The other thing to say here is that there is some distinction between the size of networks at a given mine and how they integrate into the wider environment. You may well find that they're just used for certain applications in certain parts of the facility. It could be autonomous or remote controlled vehicles. It might be monitoring of a particular dam or public or outdoor area. It could be for specific parts of the active mining the tunnels and shafts in a specific part of the underground environment, or even a processing facility. So it may well be that a given mine might have ultimately multiple networks that may or may not be integrated together. And you will also find some companies that will have networks at multiple locations around the world. They would ideally like to have the same setup, but that may not be possible either because of the physical nature of the site or because of spectrum availability. And while they need to tie into global supply chains, that's unlikely to determine the specific choice of network on a given site. Spectrum options, I'll go through this quickly. There's a lot of choices becoming available. This is very different to, say, 5-6 years ago. So there's options here where, going from the bottom, there are some unlicensed bands which can be used for cellular, private 4G and 5G networks. Happens occasionally, tends to be more used for Wi-Fi and LoRa and some of the other technologies. Some countries now have shared licenses available for industrial use on varying size quanta. So if you look at the US with CBRS, if you look at Germany with its 3.7 to 3.8 gigahertz band, various other markets that make bits of 2.3, 2.6, 3.8 to 4.2 gigahertz. There's lots of different options here. One of the things I would expect over the next, say, 3 to 4 years is a bit more harmonization across the world on that. The moment the rules vary greatly by country and some limits on what can and can't be done. Some countries have regional licenses, which are particularly in remote areas. They're actually the normal spectrum auctions or administrative licenses that could be used by mobile operators, but in an area with a low population, it may well be that a mining specialist is able to bid on the same terms if it's a regional license rather than a national license. So, Australia and Canada, I would put in this category as having certain abilities to have local networks that are based on sort of, if you like, national bands. There's also a move towards easier leasing or secondary use of spectrum. Often mobile operators might have a national network, but they're not going to build out a network in remote areas, so then they are amenable to doing some form of leasing agreement. It's better to monetize that spectrum, at least to a degree, than just leaving it completely empty. And then the last one is where a mobile operator uses its own spectrum, national spectrum, on the mine site. And that is certainly important in various parts of, say, Latin America, for example. A slightly more detailed chart in the ebook. There's a bit more detail on some of this. I have to say, the individual country allocations vary on almost on a weekly basis at the moment. Someone is announcing either a consultation or intention to license particular bands. This is a lot more of a busy slide than I had 3 years ago when I started doing some of these webinars on private networks. But there's now an opportunity to get connectivity in most countries. Sometimes it may need more of a negotiation with the local regulator or individual operators. And this is sort of teeing up what Milton will be talking about in his presentation after this. There are some unique design and planning challenges for networks in mining. There's a lot of metalwork and machinery, and some of those machines could be, as I mentioned, a 400-ton truck moving around, which is perhaps outside of the normal spectrum modeling dynamics, what you might expect in a typical environment. There's obviously tunnels, mine shafts, so it sort of could be a very complex, could be tens of kilometers of underground system. In some cases, if it's coal mine, that's not an issue. It may well be a metal mine. So there's perhaps interesting properties if you have a copper mine as to what that, or whether that has an impact on the RF propagation from the rock itself. You obviously got the shadowing effects from multiple tiers and terraces within mine environments, and the topography shifts over time. And so it's likely the coverage requirements will evolve with it. So it's not like a one-off static build of a network. Remoteness and backhaul is obviously a huge consideration, which is likely to drive demand for on-site core networks about edge computing. And then there's also some specifics which are around health and safety and just the operational management of networks, use of explosives, the awareness of risks from gases, for example, moisture and damp, all need to be borne in consideration in terms of the quality of and the certification of the equipment used. So to sort of wrap up my last slide, so although this presentation has talked about 4G and 5G, there's an awful lot of other networks that get used in mining. Yeah, historically, there's been P25 and Tetra for critical communications. There's Wi-Fi in various areas, low power, wide area networks for sensing. So there's a fair amount of LoRa, Bluetooth, and so on. There's satellite use cases, which are evolving just as fast as cellular is. And Wi-Fi is also evolving to 6E and 7 as well. So my view is that the future in mining, although there'll be a much more private 4G and 5G, there will also be more of all the others. Now, whether they are converged and integrated is going to be very, very situational. You can't just say, oh, there's going to be one converged network. The realistic future is for a measure of heterogeneity, which also allows for a bit more redundancy as well. I think that the main areas for private 4G and 5G, as I've discussed, are particularly around industrial operational technology, OT, moving IoT, moving systems, and also things like remote control, as well as local voice and video critical communications. And as I say, there will be a lot of other technologies involved as well. But I'd say, for me, this is one of the most obvious and not just early adopter, but ongoing adopter of private cellular, particularly dedicated networks of all industries. Particularly the remoteness and the dangers of that are hugely amenable to the types of technology I've discussed here. So that's me, that's my section done. If you want to get in contact with me, LinkedIn or Twitter, I've just set up a post news account as well. Details are there. Feel free to reach out with me. Otherwise, I'll pass back to Daniel and to Milton, who's the next speaker. Thank you, and I'll be around for Q&A. Milton, over to you.
Thank you, Dim. Great presentation. I think that Dim gave to us a great overview, right, about the private networks and public networks for mining, especially the motivations, right, of the sector to move to the private network. He talked about some demands and different use cases. And now I will talk about the IBWave solutions for mining environments. And because if you look in the past or some years ago, right, telecommunications were just a support for the mining environments. But today, these are very important. It's very important for the business, right? And Dean presented a lot of motivations and why you have this is the necessity to have more focus, right, in the telecommunications. But he presented some challenges, right, that we have in the mining environments, and we will talk about some of these challenges and how the IBWave solutions can help to perform the best wireless designs, right? If we do a very executive summary about the big challenges, we can see three most important ones, right? And the mining environments is constantly changing, right? For RF propagation and for wireless designs, this is a big problem, right? And if you want to do a design using a traditional site walks or measurements approach, we'll have a problem as well, because site walks are very dangerous in the mining environments. Is a costly solution, and we can add delays for mining operations. And as Dean mentioned before, when we talk about delays in mining operations, we are talking about huge numbers, right? Not only production, but any delay will impact in the ingress of the mining companies, right? And since we don't can do site walks constantly, we can have over-design problems or costly optimization problems after the first design, or mainly we are advanced in our operation. And with IBWave solutions, we can replace this traditional way using our prediction tools, right? So we can replace with fast and accurate macro and tuner predictions. So we can reduce time, you can do more accurate designs. And of course, we can have a best plan for our mining networks, right? And of course, we have a lot of use cases, especially because right now the mining companies are looking to bring the Industry 4.0 benefits to the mining operations. So right now we talk about mining 4.0, right? But in order to implement mining 4.0, we have some challenges and solutions for wireless technologies. When we talk about the mining environments or the mine designs, we can divide the mining projects into types, right? Surface mining or underground mining. Of course, we have some subcategories inside each one, but basically in both of them, we have a big problem in the environment, right? Sometimes the environment change every time, sometimes in week basis, sometimes in monthly basis. And as Ding mentioned before, we have some problems regarding the reflections, the materials, the metal, right? And even the materials of the mine will be different, right? Because we have different materials in our exploration. So we have different materials and different characteristics, right? That will impact in our wireless propagation. And of course, when the mining companies are looking for mining 5.0, basically they are looking to increase productivity, right? Increase the security much more. And of course, right now they are talking about sustainability as well. And if they look for the mining 4.0 market, they will find a lot of different applications. They will find a lot of different providers with a lot of applications for different use cases. Dean showed us a very good slide, right, showing a lot of applications for tracking, for autonomous truck, for autonomous machine, for geolocation, for security, for a lot of things. And of course, all different applications have different and multiple technologies. So if we look for the different technologies right now, we can have a lot of different networks in the same mining operation, right? Since our legacy public safety technologies, P25, UHF, Tetra, but right now we have a lot of new applications in Wi-Fi, 4G, 5G, LoRa, and much more applications, right? And much more technologies, since the most complex ones up to some just sensory ones, right? And IBWave solutions can help very well because with IBWave solutions, any ARF engineer can model any type of mine, surface mine or underground mine, and we have specific tools for each one, right? So we have a tool called IBWave Reach. With IBWave Reach, we can do any surface mine design, so we can model the surface mine environment and perform the entire design. For underground mines, we have another tool. We have IBWave Design. In IBWave Design, we can create the detailed 3D modeling of the mining, of the tunnels, of everything, and then we can do the design. And we have a tool called IBWave Mobile Survey that, with iMobile Survey, we can do the detailed digital site survey, and we can perform measurements or Wi-Fi and cellular measurements as well. So we can use to validate the design. We can use in a pre-design phase, in a post-design phase. So we have the complete solution for the entire life cycle of the wireless projects, right? And why we have two different tools for the design, surface or underground designs, because we are talking about different environments. So we have different inputs in order to recreate in the tool our environment in order to perform the prediction calculations, right? So in order to show you some examples, I have some use cases here, and basically I will show in a fast video how we can create a design, how we can how we can create the analysis and everything. And let's start with the underground mine. So in this first case, we have a typical design in an underground mine. We have two technologies using radiating cables and the Wi-Fi solution. So basically, we are looking for IBWay design tool, and here we can create our 3D modeling, importing the AutoCAD file, and then we can create the 3D modeling of the minings. You can see in detail the tunnels and all different areas of the mine. And let me just advance a little bit. So in the 3D view, we can see the detailed 3D modeling. We can see, we can model the walls, we can model the different surface, and we can define different materials, right? And we can perform a multi-frequency, multi-band design. So the tool support multi-frequency, multi-bands, multi-technologies. In this case, we have a P25 and Wi-Fi design in 2.5 and 2.4 and 5 gigahertz. And basically, we need to model the components as well. So in the tool, we will reproduce the components like the manufacturer. So we have the different components, radiating cables, the repeaters, all the distributed passive and active components. And basically, when we create our design, the tool will perform all calculations automatically, right? So depending of the cable length, the tool will calculate the gain, the losses. So we have all the automatic calculations, and we can use radiating cables. We can use Yagi antennas in the end of the cables, or you can use loads for termination, right? And the idea is to perform the complete design, not only for the propagation analysis, but in order to have the complete bill of materials in the end. After create our 3D modeling and create our distribution system or our Wi-Fi system, we just need to select different output maps. And based in the 3D modeling, the tool will calculate all necessary analysis. We'll have the output maps result with different colors. You can adjust the colors. You can see the results. You can see the result in general, or we can see the results along the tunnel. You can validate the propagation and the coverage results. You can define the next position of the next repeater, so you can perform the entire design. In this case, for the radiating cable, you can see the predictions in 3D as well. You can see the results of the map, and you can see here, for example, the components in the 3D. So if we see the components, we can validate the components heights. We can validate the entire solution in our 3D. And if you go to the production area, in the production area, we have a Wi-Fi solution. Some years ago, basically the mining companies were using Wi-Fi solutions for remote operation. Right now they are replacing the Wi-Fi for LTE, right? But in this case, for Wi-Fi, you can see that we can perform not only the coverage maps, but we can see the maximum kill data rate. So we can do the quality maps, output maps as well. We can see the throughput. We can validate the throughput in downlink and uplink. And here we have 2.4 and 5 gigahertz. The 5 gigahertz is already in Wi-Fi 6, right? The tool is already ready for Wi-Fi 6. You can do designs for 6 gigahertz as well. And we have the frequencies for cellular up to millimeter waves as well. In the 3D, you can validate all components positioning, heights. So the idea is to have the detailed design in order to avoid any other problem after the design. And in the end of the design, we can validate the entire design, and then we can generate the report. So if you need to do the build of materials, automatically we will generate the equipment list report, and we will see the detailed build of materials with all necessary resources. And if you need to evaluate costs, we can have costs for equipment, for construction, so you can have the detailed analysis in order to find the best solution and the best technology. So it's very fast, very easy to compare solutions and compare technologies. Oops, sorry. The next one is the surface mining. So in this case, we have autonomous truck use case. Now we are looking for IBWave Reach. IBWave Reach is our solution for surface mining. So in this case, in order to reproduce in the tool our RAF environment or our mining environment, we need to work with geodata database, right? So we need to import some geodata information. The geodata we can have in different formats, right? We can buy for geodata, we can use free geodata, but in the mining cases, basically the mining companies already have some elevation database information. So they have some elevation file containing the information of the terrain, right? Because they need to do some topology analysis, they need to do some analysis up to create the mining plan, right? In this case, we can import this information that the mining companies already have. So in this case, you are looking for a mining file with the elevation, terrain elevation. In this case, we have a 1 meter resolution. There's a huge resolution, right, for digital terrain information. And basically, we can import this information coming from the mining company in order to convert this mining, this vector information in order to create our DTM, our digital terrain model. And then we can create in the tool our digital terrain. And based in this digital terrain, we can import another geodata information if you have, right? Clutters, polygons, digital buildings, or any other information. And then in this case, we just need to create the information about our network, right? The tower geolocations, define the number of sectors, azimuth, heights, down tilt. We can use different types of antennas, and then based in this information, the tool will perform the calculations and the output maps. And then we can see coverage output map for LTE. We can see the results. We can define the colors like we did in the IBWave design. And here in IBWave Reach, we are looking for a typical case, right? For the autonomous truck, we are talking about connectivity, right? In autonomous truck network, we need to maintain the connectivity 100% of the time. And basically, one of the problems that we have when we advance in our operation, we have different levels in our mining operation, right? And mainly we are going down, we can have some coverage problems. We can have some coverage, some shadows of coverage, like we can see here in the blue area, we have levels of RSRP below 120, 110, right? So we start to have some connectivity problems in that area. In order to solve this problem, the mines companies normally use a mobile site, right? And then we can see here the mobile site. I call it site M. So basically, one of the problems that they have is they don't can install the site, the mobile site anywhere, right? They have very specific areas where they can place the mobile site, and so they need to define where and how are the best settings for the mobile site. And with the tool, it's very easy to place the site and run the output map again and see if we can solve the problem or the shadow problem or not, right? And remember that here we are looking for just one operation area, right? But in the surface mine, we will have different operation areas in the same mining area. And in this case, another problem of the companies is defining, okay, how many mobile sites we need to have, how many mobile sites we need to have, we need to use at the same time, and where are the best places, right? Before you use IBWave design, some of our customers need to do this positioning with measurements, right? So they need to place the mobile site and make some measurements in the area to make sure that they have enough connectivity and enough throughput, right? But right now with the tool, they can avoid all this problem, and they can create a best plan for the mobile site positioning in short time, in short time, in mid-term time, or in long time period, right? And the last one, the last one is another underground sample. In this case, we have a small cell design, and I just want to show this last one because the first one is an underground sample, but for a flat mine, right? Or the mine had just one level, right? But if you have a multiple level mine, we don't have any problem. We can model any type of mine in IBWave Design, any type of mine in IBWave Reach. In this case, in the underground, I just need to model our mine in different levels. So for each level, we can define different heights. We can define specific materials. Any material you have the specific characteristics for all calculations to perform all refractions, all necessary calculations in the mining environment. And then after create our mine, I will just advance a little bit to show you the 3D here. So now we can see in 3D our mine in top view, in the front view, like you can see in the AutoCAD man image in the left hand. And then you can create the output maps for each level. You can place the small cells. You can find the best placement. You can define all characteristics of the small cell, power, azimuth, positioning, down tilt, and then you can create the entire design. Here we can run LTE output maps. So we are talking about a gold mine, LTE in 3.5 gigahertz. You can see AirSRP design. Now we will launch in the 3D the maximum scale data rate. So we need to validate the throughput, right? We can see the average throughput, 26.6 megabits per second in the entire mine. We can validate and run uplink maximum scale data rate. So we can validate our design for downlink and for uplink. And we can perform N type of underground mine as well. If we go through some conclusions, right, talking about our project goals, basically we have a lot of project goals in our wireless network. Independent of our technology, right, we are looking for different KPIs. And with IBWave solutions, we can attain all necessary challenges, right? You could see that we can model any type of environment. We can apply all changes that we have, and we can do new analysis. We will have a very good accuracy because our propagation models are very recognized in the entire market. We can calibrate the prediction models as well, and we can perform any type of design in multi-technologies band and frequency, any type of analysis, coverage, quality, and capacity. And of course, since we have one mine and one design, we can create a different type of analysis in different technologies, so we can compare solutions. So if you have different applications running different technologies, we can find the best cost-beneficiary ratio for our private network, right? We can define what is the best resource optimization for our design. And of course, we can generate all reports and all automatic calculations. So the design is very fast, and we can validate everything very fast and very with very accuracy. The key benefits, so we can have a lot of time saving, and we can model any type of environment. We have a greater quality design because we can create multi-band, multi-frequency, and multi-technology design. You could see that we can generate any type of output map. And of course, we are ready for the future, right? If we have today our design in Wi-Fi or in 4G, if I need to plan the future of our mine operation, I need to plan for 5G, for 6G, I already have my design, right? I just need to do new studies, new analysis, and I can perform new analysis, and I can plan my investments for my private network for the future and for new technologies. I will back to you, Daniel. Thank you, guys.
All right. Thank you, Milton and Dean. That was an excellent presentation. I just want to mention the IBWave training and courses for those who want to develop their wireless network design knowledge. So we have in-class and virtual class training available at store.ibwave.com/certification program. And we have a virtual class coming up very soon. It's in January 17th to 19th. You can access it at store.ibwave.com, the link you see below, and learn more and possibly purchase the training. We have also online training with modules, standalone courses, and free courses. You can access it at community.ibwave.com. That's our Wave Runners platform. And we have a new course coming up very soon in early 2023, and that's for private networks. So definitely keep an eye on that, and you can get notified once this course is available. And now we can go to your questions. So I'll just read it out loud and then let Dean or Milton to respond to it. So the first question is from Andre. He's asking, in 3D design, heights of shafts will be different, correct?
I would say, Milton, that's a product question for you.
Yeah, can you repeat, please, Daniel?
Sure. So in 3D design, heights of shafts will be different. Is that correct?
Yes, yes. Could be different. Yeah, no problem.
Okay, perfect. The next question also from Andre. IBWave Reach is the same as InfoVista Planet. Is that correct?
Yes. In fact, we some years ago we signed a commercial and technical agreement with InfoVista, so they are partners of IBWave, and they developed IBWave Reach over the Planet engine, right? So basically, is over the Planet engines, but we have they created IBWave Reach with some asks, IBWave asks, but the answer is yes, is based in the Planet engine, yes.
All right, thank you. The next question is, how many reflections are considered in IBWave?
Oh, you can consider all reflections, right? Because talking about the surface mine, underground mine, for example, our propagation model is the fast ray tracing. The fast ray tracing taking account the reflections, right? So you can, especially for tunnels, you have the effect or the waveguide effect that we have in the tunnels. You will see very well in the tool. So we developed phase ray tracing is our own propagation model, right? So IBWave is proprietary, and yes, you can take in account all reflections.
All right. So next question is from Emil. He's asking, how deep is the underground tunnel for gold mine case?
Oh, I don't have exactly the how deep it is, but as Dean mentioned before, right? In today we have a lot of mines, and we can have 10 or tens of kilometers of underground mines, right? And we have some samples and some customers that already model very long tunnels and deep tunnels in IBWave design. Yes.
Okay.
This is Dave. I mean, just in terms of the case studies I've seen about private networks in mines, I think people have mentioned ones which are sort of kilometer more, but I'm not sure if they're gold mines or others in terms of depth. But yeah, to be honest, I guess the main distinction is what the transport down a shaft is going to be, which I would imagine in most cases is, and Milton, you've probably got a view on this. It's probably fiber on the vertical, I would have thought, and then wireless on the horizontal. But Milton, you've probably got more of a view on that than I do.
All right. We have maybe time for one last question, or yes. So what are the commercial models IBWave has?
For in IBWave design, we have 4 propagation models, right? But only 3 can be used for output maps, fast ray tracing, variable path loss exponent, and cost-231. And for in IBWave Reach, we have some propagation models available coming from InfoVista. We have P3M, we have the generic one, but we have access for more propagation models if necessary, even the universal model, for example.
All right. Thank you. So unfortunately, we don't have time for any more questions, but we'll get back to you by email, or we create a piece of content and we'll share it with you. So I just want to remind you that we will be sending a copy of this webinar to your email address, and you can also find there a link to our new mining ebook, which is also written by Dean. So you can access this without any registration. So thank you very much. Thank you, Dean and Milton, for great presentations, and thank you to everyone for joining us today. See you soon.
Thanks, Dan.
Thank you.
Thank you, Daniel. Thank you, Dean. Thank you, guys. Bye-bye.
Bye-bye.